In this module, we'll zoom in on how modern systems decide it's really you. We'll look at biometrics, behavioral signals, and continuous checks, seeing how AI both powers these defenses and learns to attack them. Along the way, we'll surface the trade-offs between security, privacy, and convenience that you'll need to navigate. Static authentication assumes that if you passed the login check a moment ago, you're still the same trustworthy user 10 minutes later. In reality, that confidence decays quickly. Sessions get hijacked, devices change hands, and AI makes impersonation easier. That's why modern approaches move toward continuous identity, monitoring ongoing behavior, biometrics, and device health to refresh rather than freeze the level of trust. Biometric identity systems all try to answer one question: how confidently can we trust this human signal? They look at physical traits like fingerprints or face geometry, and behavioral traits like how you type or walk. To judge accuracy, we track 3 numbers. False match rate is how often an imposter gets in. False non-match rate is how often a real user is blocked. Equal error rate is the balance point between those two and a common benchmark when comparing systems. There's also a key architectural decision. Do you keep biometric matching on servers or process it on the device? That choice reshapes both security exposure and privacy risk. Choosing a biometric or behavioral signal is really a trade-off between convenience, AI, vulnerability, and regulatory burden. Fingerprints and face are low friction, which is why phones use them heavily, but they're high stakes. If a fingerprint or face template leaks, the user can't rotate it like a password, and regulators treat facial data in particular as highly sensitive. Voice once looked attractive, but AI cloning has made it much riskier. Behavioral and contextual signals flip the equation. They're almost invisible to users and more resilient to deepfakes, but they demand strong transparency, governance, and clear explanation of what's being monitored. Modern identity systems don't just ask, "Who are you?" They quietly keep asking, "Does this session still look like you?" They spot impossible travel, like logins from 2 distant countries within minutes. They analyze your device fingerprint, your usual geolocation, and your network reputation. They track usage patterns such as typical login times and transaction behavior. Together, these signals create a probabilistic, constantly updated sense of whether the current activity is legitimate. Risk-based authentication treats every login as a mini risk assessment, not a simple yes or no password check. Signals from the network, device, behavior, and biometrics flow into a risk engine that learns what normal looks like for each account. It blends this with threat intelligence and anomaly detection to produce a confidence score for the session. High confidence means you glide through. Medium confidence triggers extra verification. Low confidence leads to blocking. The strategic advantage is targeted friction. You add hurdles where risk is highest, defending against scaled attacks without punishing most legitimate users. In modern systems, your in-app login is just the starting point. From that moment, risk engines watch the session in the background, following device, location, behavior, and network patterns. As long as everything stays within normal bounds, the user continues seamlessly. When something spikes the risk score, a sudden country change, unusual transaction, or unfamiliar device fingerprint, the system shifts gears. It can demand fresh authentication, limit what the user can do, or terminate the session outright. This continuous model catches session hijacking, insider misuse, and bots much earlier, while keeping most legitimate users almost completely unaware. Adaptive authentication is about matching friction to risk in real time. Most of the time, users sit in a low-risk zone, where the system runs silent checks and behavioral scoring without interrupting them. When signals look a bit off, you move to an intermediate step: lightweight prompts like a push notification or one-time password. Only at genuinely high risk do you demand strong factors, such as a hardware security key or biometrics. The core design challenge is avoiding alert fatigue. Use the minimum challenge needed, and clearly explain why it's happening when you do interrupt. Biometrics sit in a special gravity well of risk and regulation. Because they're literally part of your body or behavior, you can't rotate a password or get a new face if something leaks. Regulators therefore classify biometric data as highly sensitive and insist on strict purpose limits, consent, and retention rules. 2 concerns deserve particular attention: function creep and bias. Function creep is when authentication data quietly turns into a surveillance tool. Bias is when error rates differ across demographic groups. Together, they make impact assessments and clear legal bases non-negotiable prerequisites for deploying biometric systems. I in digital identity behaves as both shield and sword. On the defender side, deep learning makes biometrics far more accurate and flexible. Systems can fuse facial, voice, device, and behavioral signals into dynamic risk scores, so most people glide through while suspicious sessions get stepped up for extra checks. On the attacker side, the same progress powers deepfakes, cloned voices, and adversarial tricks that confuse those models. The mindset shift you need: assume both sides have comparable AI and design controls, monitoring, and governance for a moving target, not a static threat. Future identity systems should be layered, not single-shot checks. Start with privacy and consent. Users should understand what's captured, opt into it, and have real alternatives if they decline. Build in security by design. Encrypt biometrics, retain less data, and whenever possible, keep processing on the device instead of in the cloud. Then embed fairness. Routinely test for demographic bias, explain adverse decisions, and keep humans in the loop for high-impact cases. Finally, use layered defenses. Combine biometrics, device context, and possession factors, so no single AI-spoofed signal can break trust. Looking ahead, identity is shifting from one-time checks to continuous verification. Static passwords are giving way to adaptive signals that update in real time. Biometrics and behavior offer strong security, but they must operate within strict ethical governance. Context and risk scoring will quietly tune friction. Your role as a leader is to shape these systems so they enhance trust, not just control.